It's time to apply the digital skull to our actor's face, set the preferences correctly for the resolution of format we're working with. If I come up here to this window and I hold down Control and scroll the mouse wheel out, you'll see that we have a resolution of 1280 by 720, and we can come down here and actually click on the Gladiator footage, and we can see that down the bottom right it's also running at 23.976 frames per second. So if we come up to File, Preferences, and go to Frame Format, we'll see that we're actually currently running at HD 1080. So this is the wrong resolution for the overall project format, as the frame rate is also wrong as well. So we need to correct this. So I'm going to come up here and select HD 720, so that now matches up. And I'm also going to change this to 23.976. And we're going to see the 2 decimal places in that field there. So there we are, that's now set. So if I go and save that, and then Control S to save my comp, then we've now updated. Now this won't have changed anything. If I zoom out, it hasn't damaged the comp in any way. It's still running at 1280 720, but the reason I've done this now is because when you have a really complex tree and you've done a huge amount of work and then you realize you've made that mistake, there are nodes in Fusion which will get which will cause problems if you do a change like this mid-flow. And that is like a lot of the image nodes that deal with things like cropping and resizing. I won't know about the change, and of course if you change the output format it can cause some issues. So try and remember to set the preferences right up front at the beginning of the project, not like what I just did, and you should be kind of good. Now that we've done that, I'm going to do some more organization before we go on. It's possible this comp may get handed over to somebody, so it's kind of good practice to try and keep it nice and tidy and organized so that people can see what's going on. And to do that, I'm going to organize these nodes into groups. So what I've got here is I've got this is effectively our edit. So let's just move that to there and maybe move that underneath. So this is our edit that's being put together by this dissolve node. And I'm going to use a feature which is called underlay, which is sort of like a sticky note, almost like a post-it note, so that we can group these together and identify what they are. I'm going to hold down Control and Spacebar, which of course will bring up our Select Tool dialog. I happen to know, as I said, the tool is called Underlay. There it is. So it's this one here. And as you can see, we now get this kind of yellow kind of sticky note almost. You put this behind the nodes, and as soon as you kind of click off and let go, the nodes will lock to it. So whenever you move this, it'll move. But if you want to name it something sensible, I often will name it before I do that, and I'll show you why. So I'm going to drag it behind these nodes here, and I'm going to click off. And now when I pick it up, you'll see very nicely it takes everything with it. So it's a very good tool for organizing your flows and moving groups of nodes around together. But the problem comes when you want to rename it. So if I click on it to rename it, you'll notice that not only is the node underlay highlighted, but it's also highlighted all the nodes in it, which is how it moves everything. And if I hit F2 now, what's going to happen is it's actually going to want me to rename all of these one after the other. You'll see when I cancel that it's kind of cycling through everyone. So that can be a bit annoying, and it can also catch you out. So the way to deal with it, if you've already got it behind all the nodes in it, is to select it, then hold down Control and drag and deselect the nodes, so now that the only thing that's highlighted is the underlay. And if I now hit F2, I just get the underlay coming up, which I can now rename. And I'm going to call this edit, funny enough, because that's exactly what this effectively is. It's our edit that has brought the two clips together. So just going to do a Control S to save that, always good. And now we have our track. So let's do another one. So again, I'm going to do Control Spacebar, just accept that, hit F2, I'm going to call this track, and I'm going to slide this up here, and then I'm going to put the planar track in to here. I'm going to add the grid in for the moment, but we won't be needing this much longer. I'm just going to leave it in there. So now we have a fairly nicely organized flow. We're going to be doing more of this as the flow gets more complex, which it will do. So another Control S to save, and let's start by bringing some footage in, or some stills actually, so that we can start working with the scar. Let's bring in some images of our scar. So I'm just going to bring up an Explorer window, and we have our image folder here, so let's just go in there. Been provided with 2 scars for this project, so I'm just going to use this one here. And as you can see, we have a range of bitmaps that have been provided. We also have a couple of 3D models here, but we'll cover that later. Let's see what we have. We have alpha, which is obviously fairly straightforward. That's the alpha channel or mask. Ambient occlusion, AO. We have, well, I'm pretty sure that's diffuse, but it's spelled DIIF, but I'm pretty sure that's diffuse. We then have a DIS, and I believe that will be a displacement map. It's actually an OpenEXR file, which obviously implies that it's a higher dynamic range, but we won't need to be using that because that's not something that we can support in Fusion. We have a normal map, which we will be using, NM, so that's normal, and it certainly looks like a normal map. Obviously we're going to cover these, they're not bitmaps. And then we have a specular map, and we have what I believe is a world space normal map. Again, we won't be using that in Fusion as it's not required. So to bring these in, I'm just going to drag and drop, and I'm going to select them. Just hold down on Control on my keyboard, and I'm just going to select the ones that I'm interested in, which are going to be these 5. There we go. And then just going to drag them into the flow, just like that, and minimize. Now, one of the things it's done is it thinks when you do that, Fusion tries to be helpful and it merges them all together. Not a lot of use for us for this particular flow, the way we're working, but sometimes this can be useful. So I'm just going to select all these merges, hit delete on the keyboard to get rid of them. And here we are, we now have our bitmaps in. I'm just going to do a Control S to save, always good. And the first thing we can see is that they're all pretty much named the same as far as the nodes are concerned. This is going to be hard to identify these in the flow because the first part of the name is the same for all of them. If we hover over, you'll see it's a big long name. Loader 2, and then it's 3DP scar, woo, heel, male, etc. And the bit that tells us it's a normal map is right at the end. So I'm actually going to rename these because otherwise it's going to be difficult following them. So I'm going to select the first one and hit F2 on the keyboard. And this is, as you can see, is our normal map. You can see it there, it says NM. So let's call this scar. I'm going to call it norm. Why not? There we go. This is the specular, as you can see. So again, bring that up. So specular, so scar. Let's call that spec. And again, you can see this is much easier to read now. This one is alpha, so scar alpha. This is ambient occlusion. I'm not going to do ambient occlusion, just AO is good enough, so scar AO. And then finally F2, we have diff, except I'll spell it properly. Scar, even I can't spell scar, diff. In fact, I'm using uppercase, so let's be consistent. There we go. So there we are, normal, specular, alpha, ambient occlusion and diffuse. So that gets us all of those in. Control S to do a save. Now that we've got that in, we can have a quick and dirty kind of comp. I'm going to switch off auto proxy, turn on my proxy mode. I'm just going to double check that it's still set to 3. Yes, it is. And I'm going to cache up this, cache up the viewer. So let's do that. It should be hopefully nice and fast as usual at this proxy resolution. In fact, I've made a bit of a mistake because I didn't want to cache up the dissolve node. I wanted to cache up the planar track. So select that one to put that in the viewer. I'm just going to turn off our overlays for the moment. And as you, well, the caching's kind of cached pretty much down the line. You can see green bars moving, so we'll just let it do its thing. There we go, it's cached now. Quick and dirty, you know, obviously you can make very complex scars, but sometimes if you have to be quick and fast and everything's kind of at the right angle, you can just get away with something as simple as taking, say, the diffuse map and just, you know, putting it directly onto the forehead, just as we did with the grid. So I'll just simply pump that in there instead of our grid. As you can see, it's taken over. However, it doesn't look very elegant because we're seeing the whole thing. It needs a mask to hide the bits of the scar that we don't want. Also, it's see-through, and that's because you may recall we had a blend on this because of the UV grid. So if I go back to the planar track and I come over here, I can turn the blend all the way back up to 1 where it should be. So now we're seeing 100% of the bitmap. Now it's blocky because of the proxy mode, so we could just drop out and just go to auto proxy. You can see that improves it. I'm just going to Control S again. Now let's pump in our alpha mask quickly just so we can see what this looks like. Now we can't use this directly because this is actually a 2D bitmap. If I put this into the second viewer, hit 2 and fit that, this is actually a bitmap. It's a black and white image. If we go to the alpha channel, you'll see there is no alpha, it's just pure white. We can't use this directly as the mask input because it isn't a mask, it isn't an alpha, it is actually a 2D bitmap. So we do have to convert it, and the way we do that is we use a bitmap node. So with that selected, Control spacebar, type bitmap, and this gets us the bitmap node. Now when we do this with it selected, rather annoyingly, it thinks you want to put it into its mask input, which is not what we want. What we want is we want the output of the alpha to go into the bitmap, and then the output of the bitmap to go into the mask input of the scar. And as soon as we've done that, nothing happens. Why is that? Well, that's because we haven't told the bitmap node how to create the mask, because as I pointed out, there is no alpha in it. By default, the bitmap node looks for an alpha channel in the input and extracts that and feeds it down line. But there is no alpha, so we need to create one, and we're going to create one from the luminance values of the black and white part of this image by selecting this and saying luminance. And as soon as we do that, lo and behold, we now have our mask. So I'm just going to hit Control S. Now if we play that, let that cache up, you'll see there's no color balance going on here, but it's stuck really nicely to the forehead of the character. And if you're working this way with, you know, just 2D bitmaps, you would obviously put in color correction after here, but you'd also probably put in something like a transform. So if we come up here, I would probably put in a 2D transform, which would allow me to, you know, just size it up like so, make it bigger, and also obviously move it. So if we come up, if I pull back and turn on our controls, we'll see that, you know, I can move it around on the forehead a bit, and it all depends on the angle as to whether this will work in a 2D environment. You know, this is obviously just 2D image, just like the UV grid was, splattered on using the corner pin data from the planar track. Obviously we can see that if we select the planar track, you can see the corner pin box that's doing its kind of thing. So there we are, let's save that. Now that's just a quick example of, you know, how you just do a very straightforward bitmap application with a corner pin just like the UV grid. However, we're going to do something much more complex. We are going to use all these other maps here to light this properly so that it has illumination on it, and you can see all the bump maps, the normal map showing up with the lighting. We're also going to put it onto a 3D geometry so that it conforms better to the topology, potential topology of the face. So let's do that next. First though, I'm going to do a quick bit of tidying up. So I'm just going to put these back over here. Let's just, you can get rid of that node, and let's just put this stuff, get rid of that node. I'm just going to park the UV grid in the tracker box over here, just so we don't lose it in case we need it later. Okay, so there are our input images that we're going to be using. for the remainder of this tutorial. So just quick Control S to save, and let's bring some 3D geometry in so that we can map these assets onto it. Let's have a look at what we have available. So I'm going to go to Explorer, and here is our folder containing our images, but as pointed out earlier, it also contains these two files here. We have an OBJ and we have an FBX, and these are common 3D interchange formats. I'm going to load up the FBX one because OBJ is not supported by Fusion, but FBX is. This is what we're going to bring in. Now you can bring it in two ways. You can bring an FBX file in as what's called a scene, like going to the file menu and going import FBX scene, but that's designed to bring in an entire FBX scene with lights, cameras, animation, everything like that. And it can also generate a very complex node tree. And what I want to do is I want to just bring in the raw geometry without any kind of extra stuff. And there's a node that will let us do that as well. So I'm going to come back here and do Control Space to get our favorite select box up. I'm going to type the words FBX, and we have an exporter and a Mesh 3D, and the one we want is the Mesh 3D. So we're going to open this up. That'll open a dialog automatically because it wants to know what file we wish to load. So again, I'm going to navigate to the SCAR folder, and here is our FBX file, and I'm just going to open it. Okay, we appear to have a bit of a problem. It's saying failed to import. Okay, so I'll just say okay to that. So although it's actually generated the node, you can see it here, you can see it's actually connecting to an FBX file. There appears to be a problem. We can probably check that simply by dropping this in a viewer, and well, basically nothing happens. You can see there's a red dot on it, which means there's a major error. That error was the one that of course came up, and we can also double check that in the console. So let's go to the console, and it says where are we? Cannot be imported, file is corrupted or invalid while importing file. So fairly big hint there is a problem. Now Fusion does tend to be very finicky about loading FBX files if they're not just right. I've run into this before, and there are a number of workarounds. We're going to have to look at a workaround for this one, because the first port of call with a file like this is to make sure we can load it into a 3D application. Okay, so that's the first thing, just to make sure that the FBX file itself, there's nothing wrong with it, and it's just Fusion that's complaining about it. So I'm going to select it. As you can see, it's red. I'm just going to delete it. Delete on my keyboard. And now we need to go and find a 3D application and fire that up and see what we can learn about the FBX file and why it's not working.